Here, the next example we will take for the Huffman coding algorithm. So, example is alphabet with the probability 0.4, 0.2, 0.2, 0.1, 0.1 for symbols S1 to S5. Find Huffman codes and also find efficiency and variance. According to the algorithm, what is the formulas we are going to follow is first the efficiency. Efficiency is given by H by L log to the base 2 R. So here what is R? R, the value of the R will be 2 if we are calculating for the binary. R value of the R will be 3 if we are calculating for ternary, means the value code is 0, 1, 2, and our value of R will be 4 if we are calculating it for the quaternary. So here we will prefer the binary one always, so that's why the value of R will be 2. Then L is the average code length is equal to PI again, and H is the entropy, as we all know about the entropy, and last one is the variance is by sigma square is equal to summation I 1 to n PI efficiency minus L of bracket square. Fine. Now the first step of Huffman algorithm, what is first we will see what is given to us. The given to us is symbol S1 to S5 and their probability. We need to arrange all the symbols in descending order. So this is what it is already in descending order, so I return it as it is. According to Huffman algorithm, in the second step what we need to do, the least two symbols having the least probability will be. So according to Huffman algorithm, what will be the next step? We need to add last two probability and move it as high as possible. So last two means your S2 and S4. So we are going to add this, and first we will assign two numbers 0 and 1, and then the summation 0.2. We will move the 0.2 as high as possible. So according to algorithm, I have assigned 0 and 1, and now this 0.2 will move as high as possible. Fine. And then this is 0.2 will move here, and this 0.2 will move here. Similarly, on the next step, this 0.2 and 0.2. So this is 0 and this is 1. Again, the summation is 0.4. The summation is 0.4. The summation will move to as high as possible. So moving it high, 0.4, and then this 0.4 will be here, and this 0.2 will be here. Now again, the least two having the summation with 0 and 1. So the result will be 0.6. So again the 0.6 will move on the high, and the 0.4 it's on downward, and again two symbols are left. So one is 0 and another is 1. So this is how we are going to generate this tree for Huffman. You can also represent it, say this similar in the form of tree. In the next step we will find out code word. So to find out code word, first we will go by forward direction. This is S1, so we follow this direction for S1. It will come here, it will 0, and then here again it will 0. So this is what 0 and 0. So we will write 0, 0 here. Again similarly for S2. S2 will start from here. This is 0 first, then it will move here, and it will go here. So it will 1, 0. When you are moving towards the end, so it will be in forward direction, and when you are writing a code, it will be in a backward direction. Remember this. So this is how we will find path for S2. Now for S3, it is here. Now here it is 1, and then it will go on the highest one, and it will go on the lowest one. Here it is 1, here it is 1, so it will become 1 1. So what we will write here, we will write 1 1. Again for the next S4, initially it is 0, we will start from here, 0, it will go here, again it will go here, it will become 1, again it will go here, it will become 0. So what it says, 0 1 0. Again similarly for S5, starting from here 1, it will go to here. In the S5, what we get, 0 1 1, and the length of all respective symbols is 2 2 2 3 3. Is that clear? So remember, the code should be written in backward. Means if from SY you have ended here, so code should be written in this sequence. Here I have, first of all I have calculated, I want to calculate the efficiency. The formula for efficiency, as we have already seen, H by L log to R. So to find out the efficiency, what we need to calculate is H, the entropy. As we have the 5 symbols, so we will put this all the probabilities 0.4 log to the base 2 1 0.4, and similarly for all, and we'll get the probability value is 2.1216 beats per symbol. After that, length, the L is equal to pi ni, the probability of every symbol into the length of the every symbol. As we have already calculated the length here, so length here and the probabilities also we have. So what we are going to do, similarly, the 2 into 0.4 plus 2 into 0.2 plus 2 into 0.2, and what we are getting here, the 2.2 bits symbols, the value of L. Now the formula for efficiency is H upon L log to the base 2 R. So R will be 2 here because we are working with the binary. So here it equals to 2.1216. The value of H, the value of L is 2.2 log to the base 2 into 2 is equal to 96.4. And the variance is equal to sigma square, so summation of pi ni L square. So here the pi is the probability of a particular symbol, the ni is the length of the particular symbol, and L is the average length. So after calculating this, the variance will be 0.16. The variance will always be as low as possible. If you get the lowest variance, it means you are encoded your data accurately. Is that clear?